Io should be a frozen, silent moon. Orbiting far from the warmth of the sun, it should look like most other moons in the outer solar system, covered in craters, locked in geological stillness, shaped by impacts billions of years ago. By all expectations, Io should be cold, inactive, and unchanged. But Io is nothing like that. Instead of ice plains and ancient scars, its surface is covered in vast lava fields, towering volcanic plumes, and landscapes constantly reshaped by eruptions. Bright yellows, reds, and blacks stain the terrain, created by sulfur and molten rock erupting from hundreds of active volcanoes. Io is not just volcanically active, it is the most volcanically active world in the entire solar system. From orbit, massive plumes rise hundreds of kilometers above the surface, blasting material into space before it falls back like volcanic snow. Lava flows spread across the landscape, filling basins and burying older terrain beneath new layers of molten rock. Entire regions can change over the course of years as eruptions reshape the moon's surface again and again. Compared to other worlds, Io looks almost alive, a moon constantly in motion, constantly erupting, constantly changing. But volcanoes on this scale require enormous energy, far more energy than a small moon should have. To understand why Io is so violent, we have to look beyond its surface, to the powerful gravitational forces that are constantly pulling, stretching, and heating this small world from the inside. Across Io's surface, more than 400 active volcanoes erupt at any given time, making it the most geologically active world we know. Instead of a landscape shaped by ancient impacts, Io is constantly resurfaced by molten rock, its terrain continually renewed by eruptions that dwarf anything seen on Earth. Some of these volcanoes are capable of launching plumes more than 300 kilometers above the surface, nearly reaching the height of the International Space Station's orbit above Earth. These towering fountains of gas and volcanic material spread outward before falling back to the ground, coating the surrounding landscape in layers of sulfur and ash. Io's surface is a patchwork of volcanic plains, lava flows, and massive calderas known as paterae, collapsed volcanic craters that can span hundreds of kilometers. One of the largest, Loki Patera, is a vast lava lake so enormous that it could swallow entire mountain ranges on Earth. Its surface periodically overturns as molten rock cools and sinks, releasing bursts of heat detectable from millions of kilometers away. Unlike Earth, where plate tectonics slowly reshapes the crust, Io's surface is almost entirely controlled by volcanic activity. Lava flows spread across the moon, burying older terrain and erasing impact craters, making Io one of the youngest surfaces in the solar system despite its ancient origin. The colors of Io's landscape reflect this constant activity. Sulfur compounds create bright yellows and oranges, while fresh lava appears dark red or black, painting a surface that looks more like a living canvas than a frozen moon. But even with hundreds of volcanoes, the question remains, where does all this energy come from? Because Io is too small to retain enough internal heat from its formation alone. Something else must be constantly fueling these eruptions, generating enough energy to keep this world in a perpetual state of geological chaos. The answer lies in the immense gravitational pull of Jupiter. Io orbits closer to Jupiter than any other large moon, locked deep within the planet's immense gravitational field. But instead of moving in a perfectly circular path, Io follows a slightly elliptical orbit, and that small difference changes everything. As Io travels around Jupiter, The strength of the planet's gravity constantly changes, pulling more strongly when Io is closer and relaxing slightly as it moves farther away. This repeated stretching and squeezing creates powerful tidal forces that flex the moon's interior over and over again. It is as if Io is being kneaded by gravity. Each orbit causes the moon to deform slightly, its surface rising and falling by tens of meters as internal friction generates enormous amounts of heat. Over time, this constant flexing warms Io from the inside, melting rock beneath the surface and feeding the volcanoes that dominate its landscape. But Io is not alone in this process. Its orbit is locked in a gravitational resonance with two other large moons, Europa and Ganymede. Their gravitational pulls prevent Io's orbit from becoming circular, ensuring that the tidal forces never weaken. This resonance acts like a cosmic engine, continuously pumping energy into Io's interior and keeping its volcanic activity alive. Without this gravitational interaction, Io would likely have cooled and become geologically inactive billions of years ago. Instead, it remains trapped in a cycle of heating and eruption, its interior constantly churning as tidal forces convert orbital energy into heat. This process, known as tidal heating, is so powerful that Io releases more heat than all of Earth's volcanoes combined. Despite being only about the size of our moon, Io is not simply volcanically active. It is being continuously reshaped by the gravitational forces of a giant planet. And the result is a surface that never truly settles, a landscape where eruptions are not rare events, but part of a constant cycle of destruction and renewal. On Io, eruptions are not occasional events. They are part of the moon's normal state. At any given time, multiple volcanoes are actively erupting, releasing lava that spreads across the surface and reshapes the landscape. Entire regions can be transformed as molten rock floods plains and fills basins, erasing older terrain beneath fresh layers of volcanic material. Because of this constant activity, Io has very few impact craters compared to other moons. Any scars left by collisions are quickly buried beneath lava flows, leaving behind a surface that appears geologically young, despite the moon's ancient age. Some eruptions are so powerful that they can be observed from space as bright hotspots, glowing with intense heat. These eruptions release enormous amounts of energy, with lava temperatures hotter than most volcanic eruptions on Earth. In some regions, lava flows stretch for hundreds of kilometers, forming vast plains of solidified rock. Loki Patera, the largest volcanic depression on Io, is one of the most active volcanic features in the solar system. Its massive lava lake undergoes periodic overturning, where cooled crust sinks beneath the surface and is replaced by fresh molten rock, releasing waves of heat detectable across the solar system. This constant resurfacing means Io is always changing. Landscapes that exist today may look entirely different in a few years, reshaped by new eruptions and shifting lava flows. It is a world where geological time moves far faster than on Earth, driven by the relentless energy generated deep within the moon. But the effects of Io's volcanism are not confined to its surface, because the material blasted into space by its eruptions creates an environment that extends far beyond the moon itself. Unlike most moons, Io possesses a thin atmosphere, but it is nothing like the stable atmospheres of larger worlds. Instead, Io's atmosphere is constantly created and destroyed by its volcanic activity, composed mainly of sulfur dioxide gas released during eruptions. When volcanoes erupt, massive plumes rise high above the surface, spreading gas and particles across the moon before gravity pulls them back down. As temperatures drop, some of this material condenses and settles onto the surface like frost, only to be blasted upward again during future eruptions. The result is an atmosphere that is constantly shifting, driven entirely by volcanic processes. Some of the material escaping Io doesn't fall back at all. Powerful eruptions launch particles into space, where they become trapped by Jupiter's enormous magnetic field. Over time, these particles form a vast ring of charged gas, known as the Io plasma torus, encircling Jupiter and stretching across hundreds of thousands of kilometers. This plasma environment is one of the most intense radiation regions in the solar system, constantly bombarding Io with energetic particles. These interactions strip away atmospheric gases and further energize the space around the Moon, linking Io's volcanic activity directly to Jupiter's magnetic environment. Io is not just shaping itself through volcanism, it is shaping the space around it. The constant exchange of material between Io and Jupiter creates a dynamic system where energy and particles flow continuously, extending the Moon's influence far beyond its small size. And yet, despite this intense activity, Io remains one of the most inhospitable places imaginable. Despite its intense geological activity, Io is one of the least hospitable environments in the solar system. While volcanic energy can sometimes create environments where life might exist, the conditions on Io are far too extreme for any known form of biology. Surface temperatures vary dramatically, from intensely hot regions near active lava flows to freezing cold areas far from volcanic heat. The constant resurfacing means that stable environments rarely exist for long, making it nearly impossible for complex chemistry to develop or persist. Radiation adds another layer of hostility. Trapped deep within Jupiter's powerful magnetic field, Io is bombarded by high-energy particles that continuously sweep across its surface. Any organic molecules exposed to this environment would quickly be broken apart, preventing the formation of stable biological structures. Unlike worlds such as Europa or Enceladus, where subsurface oceans may provide protected environments, Io's interior is dominated by heat and molten rock rather than liquid water. There are no hidden oceans, no stable chemical environments, and no protective layers shielding potential life from radiation. Io is a world defined entirely by energy and motion, a place where geological forces dominate and stability is almost non-existent. It is a reminder that while activity can sometimes create opportunities for life, too much energy can be just as hostile as too little. And in Io's case, the forces shaping the Moon are simply too extreme for life as we know it to survive. From a distance, Io appears as a small moon orbiting a giant planet. But up close, it reveals a world shaped entirely by powerful forces. Its surface is constantly renewed by eruptions, its landscape defined by lava and sulfur, and its interior heated by the relentless pull of gravity. Io shows us how dramatically a world can be shaped by its environment. It is not just volcanically active, it is a place where gravitational forces continuously reshape an entire moon, turning orbital energy into heat and motion on a planetary scale. In many ways, Io is a reminder that the solar system is not a static collection of worlds, but a dynamic system where powerful interactions can create environments far more extreme than we might expect. And among all the worlds orbiting our Sun, Io stands as one of the clearest examples of how violent and energetic planetary processes can truly be. Join us next time as we explore more mysteries of the universe.